Well, I've got one here. Flat earthers will like this, and all NASA deniers will like this. The Earth's atmosphere is now found to be a lot larger than they first thought. This is the article here. It's in the Independent. Earth's atmosphere is far bigger than we had realised, scientists say. Earth's atmosphere is... they say the same again. And then they say the same again there. They always do that. It's really annoying. The outermost part of our atmosphere reaches nearly twice as far as the moon. So the moon is now in Earth's atmosphere. The moon that doesn't have an atmosphere. Well, you may remember recently, I did a video on it actually, that the moon does now have an atmosphere according to science, and is about 50 times as big as our own planet, new research has shown. The moon flies through the Earth's atmosphere, just like shown in the flat Earth maps, funnily enough. Also though, the sun is shown within Earth's atmosphere in that, so is that going to be a future announcement that the sun's within Earth's atmosphere? The moon flies through Earth's atmosphere, says Igor Blukin of Russia's Space Research Institute, lead author of the paper presenting the results. We were not aware of it until we dusted off observations made over 2 decades ago by the SOHO spacecraft. At the boundary of own atmosphere and outer space, there is a cloud of hydrogen atoms that scientists refer to as geocorona. One of the instruments on the SOHO spacecraft found the signature of that border, allowing it to detect exactly where it is. That can only be done at certain times, and the new research is the results of fortunate timing that allowed the spacecraft to spot the edge. The new research could allow scientists to better look for other planets like ours with hydrogen in the atmosphere. Don't forget the nitrogen, and where water vapour is often seen closer to the surface. Well, it goes on anyway to say that, you know, a load of waffle. This, like every Mandela effect, has other implications, of course. With every Mandela effect, you should always go down the path and see what else that affects. The first thing that came to mind for me was how NASA describe the way they get into space. They send a rocket up into Earth's outer atmosphere, and then it rides around the atmosphere and then breaks free, and the atmosphere gives it acceleration as it spins on the atmosphere of the Earth. So let's go to NASA then and see what they're saying about the atmosphere now. Did you ever watch a group of children playing Red Rover, arms linked up? I didn't, by the way, I've never heard of this game, but arms linked up for strength, they chant, Red Rover, let Sally come over. Sounds like they're summoning a demon up to me, but there you go. And Sally's challenge is to break through the chain of linked arms. If she does it, Sally wins. Are only girls called Sally allowed to play this game? Escape velocity, we'll go down a bit because I've had enough of Sally. Escape velocity is the speed at which an object must travel to break free of a planet or moon's gravitational force and enter orbit. A spacecraft leaving the surface of Earth, for example, needs to be going 11 kilometres or 7 miles per second, or over 40,000 kilometres per hour, 25,000 miles per hour, to enter orbit. I mean, those speeds, they're higher than they used to be. I don't know what the speeds used to be, but 25,000 miles per hour. How the hell are we achieving those speeds? Achieving escape velocity is one of the biggest challenges facing space travel. The vehicle requires an enormous amount of fuel to break through Earth's gravitational pull. All the fuel adds significant weight to the spacecraft, and when an object is heavier, it takes more thrust to lift. To create more thrust, you need more fuel. It's a cycle that scientists are hoping to resolve by creating lighter vehicles, more efficient fuels, and new methods of propulsion that don't require the same ingredients to attain great speeds. How on earth they're achieving those speeds, I don't know. So they're not exactly calling it Earth's atmosphere there, are they? But here we go. Watch NASA's Orion spacecraft breaking through Earth's atmosphere. I'm not going to play the video because it's the same sort of shite we see all the time from them. The same images you get from sending a hot air balloon up, or, you know, a hydrogen balloon up, or whatever, you know, these balloons where you can put a camera on and send them up. There's loads of them on the internet, and they all show this exact same stuff that NASA claimed to show from the space station. NASA released video on Friday of the Orion, nicely named spacecraft, breaking through the Earth's atmosphere before splashing down in the Pacific Ocean. Now, of course, re-entry into the Earth's atmosphere. How many times have we been told this by NASA? You know, oh yeah, it has to break back into the Earth's atmosphere. They seem to be able to break out of it easy enough, but to come back in, they have to get up to speed and come through, and it burns up, and they have all these special heat tiles on the spacecraft and everything. And if it comes in wrong, it'll break up on re-entry and all this lot. Well, hang on, they haven't left Earth's atmosphere. So, like I say, as with every Mandela effect, there is more implications that follow down the line. I'm going to enjoy watching NASA talk the way out of this one.